In chapter 14, we're going to talk about relationships, and we'll show how we can use the Excel Data Analyst tool on Windows in Excel to perform relationship analysis. And then we'll, on Wednesday, go into how we do it on a Mac, which will be using lower level functionality. So, looking at relationships, we have to look at whether we're dealing with categorical or metric variables. So in our variables, we'll have either levels or labels, and they identify different positions on a scale. Levels implies a metric scale, while labels implies a categorical scale. And so we'll use tools like pivot tables to help us with categorical variables, and we'll use a tool like regression or correlation to help us with a metric variable. A relationship is a consistent and systematic linkage between levels on metric variables or labels with categorical variables. So airlines might look at a relationship between frequent flying and the use of its website. Or there's other useful correlations that we can look at as well. So if we have categorical variables, they'll have labels. So for example, at McDonald's, you'll have a meal, which would be a variable, and they'll have, and it's a categorical variable, and we'll have breakfast, lunch, and dinner as meals, probably mostly breakfast and lunch. So those are categorical variables, and we see them represented on the horizontal axis as breakfast and lunch. And then on the vertical axis, we'll see the percent of soft drinks at each meal. And so with that, we can come up with some observations that coffee is the most ordered drink at breakfast, while soft drinks are the most ordered beverage at lunch. So cross-tabulation analysis is where we take two categorical variables. They're arranged in a cross-tabulation table, which is a table where data are compared in a row and column format. The intersection of a row and a column is called a cross-tabulation cell, and a cross-tabulation analysis will account for all of the label-to-label relationships, and it's the basis for determining the statistical significance of a relationship. So here we might look at two categorical variables. Have you attended a movie in the past month? And the answers to that would be yes and no. And then student classification, underclass or lower class, upper class, and then grad students. And then we get our representative subtotals in each one of the intersections that we see right here. So chi-square analysis is the examination of frequencies for two categorical variables in a cross-tabulation table to determine whether the variables have a significant relationship. The cross-tabulation table only depicts the two variables simultaneously. So the cross-tabulation is not a statistical test. The chi-square analysis is a statistical test, and it will tell us if there's a consistent systematic relationship, and if and that will help us decide whether or not we can use that particular cross-tabulation. So the chi-square formula is completed like this. It's the sum of the observed minus the expected frequencies squared divided by the expected frequencies. So to calculate our chi-square, we'll set up the cross-tabulation table and determine the cell counts known as the observed frequencies. Then we'll calculate the expected frequencies using our formula, the cell column total times the cell row total divided by the grand total. And we see this in the table to the right in step 2. Then we calculate the computed chi-square value using the formula that we just went over, and then determine the chi-square value from our chi-square table, which is either in the back of the book or in a tool like Excel Data Analyst. And then we evaluate whether or not the null hypothesis, which it always is going to be there is no relationship between them, to determine if the null hypothesis is supported. So to present a significant crosstab finding, convert your raw counts to percentages, examine row and column percentages. The advantage of these is that it will sum to 100% if you use percentages. And so you want to select either a row or column percentage based on what's the best thing to communicate the relationship. So here we see two different approaches to calculating the percentages, one with a column percentage, and then the bottom graph is the row percentage. Okay, so let's take a look at how we do this with the Excel Data Analyst. So I will open up our worksheet. We'll come up to add-ins, Excel Data Analyst, Relate, and then cross tabs. And let's look at gender versus magazine preference. Or favorite magazine type, let's call it that. Oh, you know, and I forgot to share the worksheet. So we'll do this again. Hold on, sorry, I forgot to share that worksheet so you couldn't see it. Let's do it again. I'll delete this. Okay, Excel Data Analyst, down to Relate, cross tabs, gender, and preference for magazine, or a favorite magazine type, let's say. There we go. And so if you'll recall from our last exercise, we found that for the one-seat supercycle, my particular vehicle, men were more interested in that particular vehicle than women. So I'm going to be looking at what men are interested in terms of the magazines they read, because I want to advertise in magazines that men are going to be reading in. So obviously music and entertainment is going to be at the top of my list here. Obviously, we're going to do this for a couple of things, but keep in mind there's a number of different combinations that we could do. So we're just going to do income level and magazines as a crosstab, education level and TV show interest as an example. And then the third one would be age category and radio. No need to go through and do dozens of combinations of different things. I just want you to get the idea of how to do this. Okay, so let's press on. Pretty easy with the Excel data analyst. And of course, we got those results ourselves. So with correlation, we're assessing metric variables relationships. So what we just looked at was something where we might have a categorical variable. And now we want to look at metric variables. And I think the most intuitive relationship between two metric variables is a linear relationship. And here, the knowledge of the amount of one variable will automatically yield knowledge of the amount of the other variable. So a correlation coefficient is how we measure that degree of relationship. So the correlation coefficient is a number between -1 and +1. The closer it is to either -1 or to +1, the stronger it is. So the magnitude, the absolute value or absolute magnitude of that correlation coefficient indicates the strength between the variables. A 1 and a -1 indicating that it is perfect, that it has a perfect relationship between them. The direction of the relationship is given by the sign of the relationship. A plus sign means that the relationship is such that as one variable increases, the other variable also increases. A negative sign means that as one variable increases, the other variable decreases. And here we see a sign, a line of that type of relationship. Covariation is defined as the amount of change in a variable systematically associated with a change in another. And oftentimes we'll use scatter plots to find out if we have such a relationship. Scatter plots are very easy to do in Excel. And if you're interested in delving deeper into all of these topics, please take Business Analytics, BADM. It's offered in fall and spring and oftentimes in summer. And we delve into depth into these topics. And I teach that one, by the way. Okay, so, so if we look at this one, there's obviously a relationship, correlation, as the number of salespeople goes up, so do the amount of sales. So it's a positive correlation. Here, there's no correlation, doesn't have any directionality at all. Here we have a negative correlation. And what that means is as this horizontal variable goes up, the vertical variable goes down in value. And again, here's the positive association. One goes up, the other goes up. So correlation analysis has the great ability of relating two variables that have different measurements, because there's a standardization procedure in the computation of a correlation that eliminates the differences between the two measures involved. One of the first things we want to do when interpreting a correlation coefficient is assess the statistical significance of it. If it's significant, then you can look at its strength. The closer the absolute value is to 1, the stronger it is. And of course, the direction is given by the sign, positive or negative. And we've gone over how that changes. So a correlation that's not statistically significant really is not meaningful to us, and so we would not use it. Most computer statistical programs like Excel data analyst will indicate the significance level of your correlation coefficient. So a rule of thumb for correlation strength: if the correlation is statistically significant, there's some general rules of thumb concerning the strength. If the absolute value is between 0.81 and 1, you have a strong correlation. If it's between 0.61 and 0.8, you have a moderate. Between 0.41 and 0.6, you have a weak. Between 0.21 and 0.4, you have a very weak. And less than 0.2, you really don't have any relationship at all. So we also can do the Pearson product moment. So the Pearson product moment correlation is going to be used to determine the linear relationship between two metric variables. Again, it's going to give a value between -1 and +1. The closer the absolute value of this coefficient is, the higher the strength. And let's see how we can use Excel data analyst to do this for us. So I'll switch over to Excel data analyst. Okay, here we are. So again, we'll go up to Excel data analyst, go to relate, then to correlate. And in this particular example, I'm going to correlate the preference for a one-seat supercycle to the various lifestyles. So I'm kind of interested in how we might, obviously with the crosstabs, we can find out what media we might communicate to our marketing, our target persona. With this analysis, we can figure out how, or we can't, but marketing can figure out how they might be interested in communicating with them. Our job is in marketing research is just to tell them that here's the media that they're interested in, and here's a lifestyle choice. In other words, a high-level psychographic profile of the persona. And then they will know the messages that are appropriate for a novelist, an innovator, a trendsetter, and so on. So let's see if there's something of use here. And again, this is for my vehicle, the one-seat supercycle. You would be interested in the two-seat runabout. So it looks like I have a moderate correlation, and it's just on the edge between strong and moderate at 0.79 with the novelist personality type. So we can convey that to marketing, and since they'll be working with, in our shop, everybody will be working off the same lifestyle framework, they'll know how to tailor messages to the novelist persona. But that's definitely the strongest correlation we have. Okay, now to go back. Now we're going to be doing crosstabs and correlation. We won't be doing regression in this particular exercise for our class project. So those are the two that you'll need to know in terms of Excel data analyst. And as I mentioned, we can go crazy trying to do all these combinations. So I just want you to do income category and preference for magazine, education category and preference for type of TV show, and then age category and preference for radio show. And then finally, we'll have a correlation between your car, the two-seat runabout, and the various lifestyle approaches to find out if you have a strong correlation that you can tell marketing. You probably want to communicate to them, as in my case, a novelist. Okay, but for completeness, we'll go ahead and finish up our discussion this week by looking at regression. So if you'll remember the formula for a line from high school algebra, y equals mx plus b. In statistics, they call it y equals a plus bx. And we're going to be doing predictive analysis in regression. And that's where we have two or more variables are used to predict another variable. In bivariate regression, we deal with only two variables: the dependent variable, the one we're measuring to see if there is an effect, and the independent variable, that's the one we control. So that's the one we change, and we think of the independent variable as perhaps an indicator that will tell us the value of an associated dependent variable. So the dependent variable is the one that's predicted, and it's customarily termed y in the regression straight line equation. The independent variable is the one that's used to predict the dependent variable, and it is the x in the regression formula. And so here we can see the way we get the, well, let's put it this way, the way Excel data analyst gets the slope of the line. And it's going to be the ratio of the standard deviations times the Pearson coefficient. And then we take, once we have the B, the slope of the line, then we take the average of the Y's and the average of the X, and then we get the Y-intercept A with the bottom formula. So the values of A and B have to be tested for statistical significance. And to determine statistical significance, regression analysis requires that a t-test be done for each parameter estimate. So since a perfect correlation of 1 or -1 is almost never found, we know that our regression prediction will only be an estimate. Regression analysis provides for a standard error of the estimate, which is the measure of the accuracy of the predictions of the regression equation. Residuals are the differences between each predicted Y and X value in the data set compared to the actual X value. And we do, again, go into this in great extent in business analytics. And we spend a couple of weeks delving into a regression and correlation. So we study it in a great deal of depth. And again, I teach that. It's taught almost every semester. So if you're interested in digging deeper into this, I highly recommend business analytics. Okay, so here we have a range at a 95% confidence level. We have the predicted values, and then we're going to use our standard 95% confidence level. That means we're going to have plus or minus 1.96 times the standard error to get an upper line, and we subtract it from the values to get a lower line. And our actual results, we have a 95% confidence that it'll be in this area that is designated here. So we can use a regression equation to predict the dollar amount of grocery purchases that would be associated with a family of a certain size. And we see the calculations we go through, and the interpreting these numbers is what we're saying is for a typical family represented by the sample, the expected average grocery purchases amounts to $175. The 95% confidence interval reveals that the sales figure should fall between 136 and 214. And then the R square, that's the coefficient of correlation. And it shows how much of the dependent variable is explained by the independent variables. Now, multiple regression is where instead of having one independent variable, we can have two or more independent variables. But otherwise, it's very similar to what we looked at in terms of linear regression. The nice thing about it is we can add in multiple variables to help us decide what the best approach or what the best estimate is for our dependent variable. And so, for example, with Lexus, you can have their attitudes towards the Lexus, their attitudes towards their current automobile, and their income level, and come up with a prediction on whether this particular couple would be interested in buying a Lexus, which is one of the higher priced automobiles. So multiple regression is a very powerful tool because it tells us which factors predict the dependent variable, which way, in other words, the sign, each factor influences the dependent variable, and how much the size of the coefficients, how much each factor influences it. So multiple R is the coefficient of determination, and it will show us the overall strength of the linear relationship. And it ranges between 0 and +1. And it's, again, the amount of the dependent variable explained or accounted for by the independent variables. And we do spend a good amount of time in the data analytics class on that. But we're just covering it here so you know that it is being done. Okay, bivariate regression is used for prediction, whereas multiple regression can be used for prediction and understanding and as a screening device. As a tool for understanding, multiple regressions may use standard beta coefficients, where that allows for directly comparing the importance of each independent variable. So we can also use multiple regression analysis as a screening device, which means it allows the researcher to narrow down the many independent variables thought to predict the dependent variable to a smaller, more manageable set. So when regression is used as a screening device, the items that we'll look at in terms of our report, and Excel does give an excellent report on that, the dependent variable, the statistically significant independent variables, signs of beta coefficients, and then the standardized beta coefficients for the significant variables. And again, we've got the ability to use regression in our tool, Excel Data Analyst. In addition, there's something called the Data Analysis Tool Pack. So that's a little more powerful a tool than the Excel Data Analyst, and that's what we use in business analytics. Okay, so we also want to present our analysis findings. So we're going to, for regression, look at the dependent variable, statistically significant independent variables, the intercept, the R-square, and the standard error of the estimate. And here's a flow chart on relationship analysis. If we have a dependent variable, then for metric variables, we use Excel Data Analyst. If we don't have a dependent variable, then we're going to see, is it a categorical relationship or a quantitative relationship? If it's categorical, we'll use relate crosstabs. And if it's a metric, we'll use relate correlate. And then we look at the observed frequencies or the correlations to determine the strength of the relationship. Okay, any questions on this? All right, on Wednesday, we'll go through how we do these exercises using just the raw functions in Excel. For the Windows folks, you can use Excel Data Analyst as we did here. What you would be doing is you'd be using crosstabs analysis to look at the cross-tabulation relationship between income category and magazine, education level and TV, and then age category and favorite radio program. So obviously there's dozens of combinations. Don't do them all, just do those three. I just want to see that you have the correct idea on how to do this. For the regression, what we'll be doing is the relationship between your car and lifestyle. Like the one we did in this class a couple of minutes ago was my car, the Super Cycle, one-seat hybrid, and lifestyle. And we found that the novelist lifestyle has a fairly strong relationship. So we can tell that to marketing, and they can formulate their messages appropriately. Okay, any questions? All right.